So let's dig down into how we actually think about apps, devices, and the cloud. And it really comes down to 3 different reasons why that would actually happen. And a lot of the times, or up until now really, when we didn't have this option, we were thinking about, I can only do so much with the device. And there's only, as the device gets smarter and faster and more space, still at the end of the day, it's still a limited device. You still have those constraints in terms of what it can do. For example, you're not necessarily going to want to do video encoding on a phone, right? But that doesn't necessarily mean that your application shouldn't have access to those resources if that's what you need. So if we think about it, when we're looking at these different scenarios for applications, we're actually thinking, hey, you know what? What if I look at my application on the device as just, we'll call it a sexy user interface for something that I'm actually doing elsewhere? And if you start thinking about it that way, that elsewhere actually becomes your cloud. But your application now looks like it's doing that. And for all intents and purposes, for your user, the user thinks that the application is doing it. But at the end of the day, it's actually doing it elsewhere. More importantly, and Paul will touch on this a little bit later, your users don't want to care where all of this information is. They just want to have access to it, but have access to it in ways that is natural to them. And so that where, as a developer, you have to think about, well, how do I enable all of these natural experiences with the device and with my application, yet still be able to give all the features that I want? Now, the other option, if we're thinking about applications and we're thinking about devices, before cloud, you had to think about these things in terms of, well, hey, I need all this infrastructure to be able to support my application. And as we see the larger companies, like for example, the Facebooks and all that kind of stuff, they have huge data centers and huge access to computing power. So you might think to yourself, well, if I want to come up with the next social network that has applications for devices, let's say, and websites and APIs and so on and so forth, how do I do that? I don't have the same access to resources as a Facebook would. Right? So again, we're thinking about cloud here, and if you remember what we talked about last week, and again, if you're watching this, if you missed last week's, check out the on-demand, because we actually went into this into a little bit more detail. The whole point of this stuff is that I don't actually have to worry about provisioning all this stuff ahead of time. More importantly, I don't have to worry about paying for it. Right? So as I'm building my application, more importantly, as I'm building my the usage of my application, that's when I start worrying about the cost. So I can actually compete and I can actually run my business almost like a Fortune 500 company without having to spend that kind of money on doing that. And especially if you're thinking about if you're a startup or if you're a student startup, even better, you're not necessarily thinking, well, how do I build a data center like that to support my mobile application from day one? It's just simply not part of the equation. Well, now that's not so much an issue anymore. And last but not least, when we think about why we take the functionality out of the device itself, and let's say we put it in the cloud, is if you think about it, when you go to download an application right now, let's say, I don't know, it's a social networking type of application or a recipe type of application, you're actually going to go to the page or the Windows Phone store. The point being, every application is available on multiple platforms now. And it's almost an expectation of users that your application be available, because you don't want to make your potential users decide on which device they want to use just because they want to use your app. The loyalty is to the device, not to your app. So if you want people coming back to your app, and in fact you want to increase the reach of your application, you want to start thinking about cross-platform. Well, again, how do you do that? If the functionality is maintained in the device itself, it's maintained in the device itself, in which case you can actually use it across multiple devices. But take that out of the device, put that up in the cloud, and as long as you're talking standards, let's say you've created REST-based API, or you're using WCF, or whatever it is that you're using, you can now enable those applications to access whatever functionality they need, and you're not duplicating the code every time for each one of those platforms, right? So you're starting to think about, it goes back to just standard stuff that we think about in terms of developing, decoupling all of these things so that you can put things in a distributed system. But when you're talking about devices, that distribution system is actually quite large, right? Because you're not thinking, well, okay, my data centers, let's say, or my main area of coverage is the GTA, the Toronto area. And nowadays, you might have something here, but maybe your offices are in Vancouver, whatever. These devices roam around, which means I need to make sure that as they're roaming around, you have the same app experience in terms of performance, but also in terms of capability, regardless of where you are across the country and even across the world. Again, before the cloud came into the picture, that was a little bit difficult to do because you needed to manage those data centers. But as you heard from last week, when we're talking about putting this stuff in 8 different data centers across the world with additional nodes across the world as well in terms of distributing content, things get a little bit easier to do. So your top 3 reasons, I can think of several others, but we'll keep it to those 3 because really those ones are the essential ones for what we're talking about here. When we focus on the functionality, or when we focus on potentially the constraints you have on a device, usually it comes down to 4 different things. And first of which is usually storage. We'll talk about that, identity communications, and then talk to you a whole bunch of other platform services that are available for you to actually take advantage of. So to recap, before I dig deeper into each one, just wanted to make sure that when we're thinking about these devices, reason why Windows Azure is as compelling of a story as it is again, think about it, we talked about this last week, as a developer, you don't want to worry about the infrastructure, especially for things that roam around. It's one thing if you know all of your traffic is coming from web servers, or you know that that access is coming in from a specific office. When it comes to managing the infrastructure, and if any of you guys wear a double hat and or your system admins as your full-time job, and you're kind of thinking about this, well, you're probably shaking your head thinking, yeah, this would be a pain in the butt to manage, right? So you're thinking about, or you want to be thinking about, as how do I get my backend to my devices or my device apps into the cloud as platform as a service? Again, I won't go too much into platform as a service here. If you want to catch up on what that is, check out the on-demand stuff from the first workshop, and we go into that. The most important part, though, of why we're talking about Windows Azure as a backend for these applications is actually from the automatic OS patching, which obviously you get from platform as a service by nature. But more importantly, it's that scale. Okay? And that scale comes from the fact that you can start off with the one instance today, grow it as you need, it doesn't matter. And actually, by the way, you probably should start with 2 so that you have that high availability. But listen, if you want to start with 1, that's cool too. Okay? Point is, you have all of these platform features in place for you that allow you to actually get these devices up and running, these applications on the devices connected, ready to go, and worry about how does that scale out at a later time. So now let's focus specifically on storage. And one of the reasons why storage is actually a big concern, if you will, from an applications perspective is, think about it. A device these days comes with what? Comes with 32 gigs, 64 gigs, or even a phone maybe less, 20 gigs, let's say. But that 20 gig is shared with the operating system. It's shared with other applications. It's shared amongst all the various different uses of the device. More importantly, depending on the type of the device that you have, yeah, you could probably put in a SanDisk or an SD card or whatever to increase it. But again, you only increase it by so much. So at the end of the day, storage does in fact become one of your constraints that you have to keep in mind when you're building device-based applications. Now, think about it from a user perspective. You think about it from the other end saying, well, okay, if I have one app that's going to consume the entire storage that I have on the device, chances are I'm going to uninstall that application. As much as I love the application, at the end of the day, I need to be able to have other things running on the device. So you don't want to be that application that messes with people's storage. So what's the solution? I want to say outsource, but it's not really outsource. It's take out that storage requirement from the device and access it from the device, but really that storage is up in the cloud. Now the nice thing about that is that you, with the distributed network, as the device roams around, that content or that whatever you're storing in the storage is actually going to come along with you, or the user will be in fact connecting from the spot that is closest to them so that they actually get that content fast. So you're thinking, well, okay, if I put my data, let's say, up in the cloud, that I'm going to start having latency issues. I'm going to start having issues potentially of not being able to get at the data. What if I'm offline? True, those don't go away. Now, what you have to do in your applications, you have to make them smart enough to be able to know, well, what makes sense for someone to use offline? What makes sense for someone to use online? Or maybe even implement a caching mechanism to say, well, you know what, if there's a resource that isn't going to change that often, I'll cache it on the device, and every once in a while I'll check the storage to make sure that I have the latest. So there are various different ways to get around this. The idea being, if your app, let's say, you're watching videos, right? And each video, let's say you're even watching HD videos, each one of those can take a good couple of gigs or whatever. Now, let's say if you have the ability to stream them, now all of a sudden you're saying, well, hey, as long as the user experience is not affected in a negative way, then why do I need to keep it on the device? Now, let's look at options that we have in terms of storing data up in Windows Azure. First of which we have the table storage, which really is a beautiful way of storing data that you need access to from the application, but you don't necessarily need to get into all the relational capabilities that you have from an actual database. You just need flat tables that just store data, and potentially that data might be user settings or session settings. Let's say it's a game, and you want to make sure that if the person is playing on device X, then they go and continue that session on device Y, then they're not starting from the beginning, but rather they're actually starting from where they left off. You need to make sure that you have that mechanism to be able to communicate between the two. So tables is actually quite good for that because you can easily save that data there. The bursts of data that you're going to be sending from the device over to the table storage is actually quite small from a payload perspective, so you're not necessarily worrying too much, unless of course you're creating a chatty app, but we can get into that. You're not worried too much about that data transfer back and forth. By the way, before I go on, as you're thinking about these things, you also want to think about from an app perspective whether you're going to enforce that it's Wi-Fi only, let's say. For example, I know some of the GPS applications want to make sure that you're on Wi-Fi because they do download a lot of data. Or you're okay with either Wi-Fi or cellular, one or the other, right? But if you're going cellular, you want to make sure that that communication back and forth between your application and the cloud is actually kept at a minimum to what you actually need to make sure that you can serve on the data plan. Now, when we're talking about saving files, images, documents, videos, whatever it is, actual binary data, that's what we have blob storage for. And again, same concept as with the tables. You want to make sure that the communication back and forth is as minimal as possible. But now you're actually starting to put data outside of the device. So if I have an application, let's say it's a camera type of application, and I do a whole bunch of funky stuff with the image, I want to save that somewhere. Sure, I could save it to the hard drive on the device, but what if I want to access it from somewhere? So you can actually make a choice to say, hey, do I automatically save to the cloud, in which case you would write directly to blobs, or let the user choose to say, do I want to store it locally to the cloud or to both? Right? So you have those options. The idea being, if you're thinking about these things as a user and you're thinking about these things ahead of time in terms of what you would want to do, then you now take all of these various different options that you see on the screen and you can mix and match where they make sense. You don't have to do one or the other. Now, when we're thinking about communicating between potentially multiple devices, or even if you have some sort of data that you're worried about, let's say I'm working in an application and it's something sensitive to a hardware failure, or let's say I have to reboot the slate, or I have to reboot the phone for whatever reason, then simple kind of conversation like that I can actually store up in a queue. which again is just another service that's available from storage that gives you that mechanism in order to save information quickly, pop it off when you need it, or potentially even go across multiple applications in order to get that data across. You don't have to worry about saving it to a database if you don't need to persist that data. Right? So it makes communication quite quick between your device-based applications. And then last but not least, if you actually do need the relational capabilities, right? You're not necessarily going to have a full-fledged database on the device. Some devices have call it a compact version of a database server or something that an application would use like a database server. But there may be applications, especially business applications, where you actually need the capabilities of an actual relational database. So you're not going to attempt to, I hope not, you're not going to attempt to write one on your own. Right? That doesn't make any sense. And you may not want to start hacking around with the device to get some sort of server running of some sort. So where do you go? You go outside of the device, you go into the cloud. And in this case, now you have actually two options. And you heard Bruce talking about this last week, where you have either a Windows Azure SQL database that you can use, or you can use a SQL server in a virtual machine. Either way, the server itself and the database is outside of your application. Makes it nice and easy to be able to use this database. More importantly, you're not actually worried about the safety of that data, right? Because it's not stored on the device. If the device gets stolen, or you're not able to use the device anymore for whatever reason, the data's not there. It's somewhere that's accessible and maintainable for you so that you don't have to worry about it. Now, though moving all this stuff out into the cloud seems like a great idea, and certainly in this particular session I want to make sure that you know what's possible, but also some of the caveats in doing that. One of the things that you have to keep in mind when you're working with storage off of the device is this idea of your security. And in terms of security, I actually mean the secrets that you're actually going to use in your application. Now, if you've played around with storage at all, or if you haven't, then I'm going to tell you that to order or to access storage, you actually need to have what's called a secret key. And that key is effectively a string of characters that authenticates your app against storage services. So basically what that means is that in order for an application to use those, whatever you have in storage, and that includes tables, queues, and blobs, the application actually needs to have that key. In a web application, not so much an issue because you control that infrastructure as well. But what happens now if you put that key in a device that you are actually giving to someone else? In theory, with enough effort, they can actually decompile your application, get at your keys, and now we have a problem because they can use those keys now to access your storage directly. So what we want to do is we want to see what's possible in terms of kind of getting around that to make sure that you can still use the capabilities, but you want to make sure that you use them securely. So how do we do that? We basically let's go do this. Okay. So we proxy the request. Now, by the way, this architecture is just an example. If you want to roll your own, or there's a particular architectural pattern that fits better with what you're doing, go ahead and do that. What I want to make sure that you have here is sort of how to think about these things so that you make sure that your data is secure at all times. So when we think about proxying the request, you look at the device, it's actually going to call out to a web role, which is a type of cloud service, which is a type of platform as a service. And that client is actually going to request the data of the web role. Then you can have the web role going out into table storage, blob storage, whatever storage it is, and actually get you that information and then send it back to the device. Okay? Now, on the database side, same concept. Right? You don't want the device connecting directly into your database because what happens is, again, that username and the password, plain text, technically the connection is encrypted, but the string itself is still plain text. You don't want that going across. So what do? We proxy it like we did the last time. Right? Device makes the request to the web role. The web role relays that over to the Windows Azure SQL database, and then we get the information back, and then that sends that to the client. Okay, nice and simple. Now you might be thinking to yourself, well, okay, I might be introducing a middleman here because, well, that web role, kind of takes a little bit of time and also needs a little bit of code, which is technically true. But think about it from a security perspective. Think about it from a logging perspective. Think about all of these different things that now you technically have the capability to interject something in there if you needed to do whatever, auditing, logging, authentication, whatever it is. And by the way, conceptually, this is what it looks like. You could actually put your own services in that web role, or the next session, James Chambers will actually show you how to use Windows Azure mobile services that will actually do a lot of this for you. And that's the beauty of it, so that if you don't want to worry about rolling your own service in a web role, then you can actually use mobile services to do that. So I'm not going to steal his thunder. I'll make sure that he goes through that. But if you needed to do more complex things, after you watch a session, you're like, yeah, okay, that works, but I need to do more. This is sort of the architecture that you'd be looking at. Option number 2. This is if we're thinking now about performance and we're not too worried about getting some sort of server code in the middle there. We want to make sure that ultimately from a scalability perspective, if you remember when we talked about storage, we talked about the fact that files will scale on their own if they're in blob storage. So ultimately what you want to do is you want to make sure in one way or another that your device is actually connecting into blob storage directly. How do we do that? We do that with something called shared access signatures. The way that works is actually you still need that web role in there. But rather than the web role now relaying the data or making the calls against storage for you, what it's actually going to do is almost act like a token dispenser. And what it's going to do is it's going to send you back what's called a shared access signature, which is effectively just a string that allows you to, or that you're going to pass on, that basically says, yes, I've authenticated, yes, I have access to this, but I only have access for a certain amount of time to do a certain amount of things. Okay? So it's not free for all. Send that back into the client, then the client actually connects to the resource directly in storage. This is actually a beautiful thing because now if you think about it, you've enabled the scale because you've taken out the middleman in terms of actually getting what is actually the heavy payload, right? Because talking back and forth with the web role to get the signatures is actually nothing. Where the issue comes in is when you actually have that file that the web role needs to download itself and then pass on. So things get a little bit slower that way. But if the web role is just sending the key back, then that device is sending that request over to storage. The communication to actually get that heavy payload is directly from the client and storage. There's nothing in the middle. So you can enable content delivery network. If that client, let's say, is on the other side of the world, it's actually going to route it through the content delivery network and ensure that whatever is downloaded from the node that is closest to that particular user. So it actually makes sense to go directly to storage if you can. Okay, so now when we're thinking about offloading work to queues or that communication between the device, I didn't mention this before, but I want to make sure that I mention this now. One of the reasons why you actually want to offload work into a queue, the modern app thinking, if you will, is you actually want to get response back to the user as soon as possible. So for you, those of you guys who are already writing a Windows Store applications, or you're using some of the new features in the .NET 4.5 framework, you'll know async and await. Right? So that's basically being able to spin off other threads to make sure that that work is happening elsewhere while you do something else. Same concept here. Rather than having that communication back and forth, let's say I want to encode a video, or I want to stitch a couple of videos together. Something that is a long-running process like that. I don't want to have that on the device because I want to make sure that the device or the response is given back to the device as soon as possible. So in this case, and this, by the way, is also the case if I have multiple worker roles in the back end, I want to make sure that I'm not talking directly to one. If I'm talking directly to one and that one goes down, we have a problem. If I'm talking to this queue, which is actually guaranteed to be up, and it can spawn that off into however many different instances of the other side that I have, all that's taken care of for me. Point being, the device doesn't have to worry about it, or the app on the device doesn't have to worry about it. So the way this works is On the device, I make a write call onto the queue, and I put whatever I need to do in there. So if I need to tell it to, hey, go do this, or here's a whole bunch of URLs for videos to stitch together. Whatever it might be, you're sending the instruction rather than making the actual API calls themselves. Now, on the other end, you actually have something monitoring this queue. So as you're getting in the request to do work, we'll call it, the worker role, or whatever you have it hosted in, probably best to have it in a worker role because it doesn't have that user interface requirement. That worker role then continues to pull the queue and says, hey, do I have new work? And if I do have new work, then what it does is it actually pulls those instructions, goes off and does whatever it needs to do, and then, sorry, I went too quickly. When it's done, it then sends the response back into the queue. The device can actually then go look it up, and everything is honky-dory. The point being, the device wasn't the one brokering all of this orchestration. Okay? So the queue, simply by being a mechanism for putting the information there and taking it off of the device, basically point being that you're alleviating the device and the app on the device from being the orchestrator. So on the user side, you would effectively say something like, hey, we've gotten your request, or we've gotten your job, or whatever makes sense in the lingo that you have, and then we'll let you know when it's done. We're going to talk about it in a little bit in terms of how we let you know. There's a couple ways to do that, but for the purposes of right now, we'll leave it at that. Now let's talk about identity. Again, if we think about what stuff that we don't want to do on the device, stuff that we don't want to do on the device, the first one was storage. This next one, identity, is not so much that we don't want to do it on the device, but it could be from, let's say the device doesn't have capabilities. For example, let's say you're building an iOS application and you want it to talk to Active Directory. You may not have the ability to do that. In fact, last I checked, you probably don't have the ability to do that. With an external service that you can now tap into that is in fact cross-platform, now you have that capability to do that. Here's another example. If you want to have in your application the ability to log in or to authenticate as a user, where are you going to do that? You're going to store a list of username and passwords on the device? Probably not a good idea. More importantly, if we go back to the 3 reasons why we said cloud at the beginning, we said we want cross-platform. Okay, so if I'm saving my username and my password on the device, I can't go to any other device. If we think about it from a security perspective, it's on the device. If my device is taken or crashes or whatever it is, data is gone. And more importantly, it's the same functionality every time. So why recreate the wheel every time in every application that I need to create, or every application that I need to have identity? What's the point of creating it every time when you could technically outsource it to a service that does just that and does it really well? So what we have in the Windows Azure world is actually a service called the Access Control Service. And what it does is it actually puts all of these different things together, all of these different identity concepts together. Now, you could create your own, whether it's a token dispenser or just an API that authenticates usernames and passwords, whatever it is. You could do that, and you can have that running in a web role or a website, let's say, doesn't matter. And then you can use the ASP.NET membership providers to enable that in the application. Nothing that says that you can't do that. But if you want to use something like, and by the way, this is becoming very much so a requirement from a user perspective, that applications don't have their own username and password requirements. As a user, and you're probably thinking this, right? If I'm going to an application or I'm going to a website, the last thing that I want is to be able to, or to have to create a username and a password for that particular application. And more importantly, then have to remember what I set it to. So these days, you're finding applications that have Facebook built in, that button that says connect with Facebook, or connect with Twitter, or sign in with LinkedIn. All of these guys, what are they? They are identity providers. And what they've basically done is said, hey, you know what? Especially Facebook. I mean, I use my Facebook account all the time. I use my Twitter account all the time, Jay Rosenblatt. Shameless plug there, but hey. I use my Twitter account to sign into various different various different applications. And now technically I could build it into my application so that I connect directly to Twitter, handle all of that brokering, handle the request back, and then if Twitter decides that they want to change their mechanism, well then guess what? My application is broken, so I got to go and change it. In the access control service world, so if I, as an application now, am making the request out to ACS, so Access Control Service, I'm making the request out there. I'm using a standard API to access multiple different identity providers. I'm actually letting the user decide what they want to log in with. More importantly, if you think about from a security perspective, not only am I not storing that information, and let's say even you were to create your own and you are hosting, in fact, in the cloud, you are still responsible for those usernames and passwords. So if I want to alleviate myself of that worry, now, I don't know about you guys, but back in the day when I was building applications, I swear I may have lost sleep several nights because I wasn't sure whether my routine was rock solid. I was worrying about SQL injection. I was worrying about all these things. And as much as I put in all of these things to protect against it, you never know, right? I can only put in there what I know of. Now, in this world where I'm saying, well, you know what? I actually don't want to have anything to do with identity. I actually just want to know, are you authenticated? Are you not? Are you who you say you are, or are you not? Now things become beautiful because I can actually tell access control, hey, access control, you are built for this. More importantly, by the way, there's a whole bunch of security experts that work on just that to make sure that it's rock solid. And at the end of the day, too, even access control is not the one that is storing all this information. Let's go back to our Twitter example. It's actually just relaying for you that message to Twitter, does all the authentication, gets it back, sends it back to your application. So you're not worrying about it. Access control is not worrying about it. So you might say, okay, fine. So why bother use access control? Here's the beauty of it. One API, a couple of very simple calls. Now I've enabled access to a whole bunch of identity providers, and they keep adding in more, which is great. So out of the box, I could do Live ID, I could do Facebook, I could do Yahoo, I could do Google OpenID. Or if you're building an application that needs Active Directory, well, then I can actually use Active Directory Federation services to connect into my on-premises AD, do the authentication there, send the response back to the application. Makes things very easy. Now you're probably thinking to yourself, okay, great. So I have, so this works really well for Windows Phone apps. It works really well for Windows 8 apps or Windows 8 Store apps. Absolutely. But guess what? Access control, like every other service that is in Windows Azure, is just a REST-based service. So I actually know of a couple of applications that are iOS applications that are in fact using just access control to access AD so that they don't have to worry about anything else. They could just make calls back and forth. They don't have to worry about jury-rigging their app to actually make the necessary calls into Active Directory. So it makes things nice and beautiful because, again, you're just making that API call, and when that API call comes back, you get a token, and you can do whatever you please with that token. And even in your own application settings, where you're saving that information, you're saving that final token. So you're not actually saving any kind of sensitive information about the user. That's actually coming from the identity provider. Makes things very simple for you as the developer to actually get identity now built into your applications. When we're thinking about security, different security challenges, right? It doesn't end. There's a whole bunch of them, right? A little animation here. I love going through this one, right? Because all of these different things actually factor into what you need to worry about, especially when you're doing device-based applications, right? Synchronization, integration with Facebook, Facebook authentication API, so on and so forth. I'm not going to go through. Point is, there's a whole bunch of different challenges that you need to worry about. Right? So when we think about simplifying all of that, we think about claims-based architecture, which technically is the way to go these days, where you're worrying about roles more than you are about users. And if you actually do need the user information, you can get that too. But check out how this works, right? With ACS, and for those of you guys that are in fact building .NET-based applications, again, Windows Phone-based applications or Windows 8, Windows Store, Windows 7 applications, whatever. As long as you're using .NET, you actually have this wonderful thing called the Windows Identity Foundation, which is actually just an extension of .NET that adds in all of these capabilities so that you can actually just configure to use access control services instead of actually having to build the API right in. So it actually works quite well. When we talk about communications now, right? So we covered storage, we covered security, or we covered identity. Now we're saying, going back to those three reasons, we're saying I need to be able to communicate across platforms. I also need to be able to communicate potentially with myself over time, or all of these different things. And more importantly, remember when I said before that if you spin off some work and you basically are putting that work on the queue, that queue is communicating with that worker role, at some point you need to know when that's done, right? So in the past, we've done the typical thing of, hey, poll every once in a while, whatever it might be for your application, 90 seconds, a minute, 5 minutes, whatever. And if there's something new for you, great, you pick it up, you do whatever you need. But what if there isn't? You've technically wasted that data packet from the device app to the cloud because you thought there may be something, but there wasn't. So when we're thinking about apps and we're thinking about devices, again, you want to be very conscious of that chattiness going back and forth. How do we solve that with the cloud? Very simple. Two methods we're going to talk about. The device-initiated one is sort of that typical one that you're used to. That is me polling. But the new aspects of the platform is actually this cloud-initiated business where Windows Azure can actually tell me that I have some stuff that I should probably care about. And you can actually then make the decision of how you read that. So I'm going to go into that in a second. Let's look about these device-initiated ones. When we're thinking about device-initiated, we're thinking about I'm sending a request to the server saying, hey, do I have work? Or do you have something for me? Whatever. Now, the nice thing is that that can support whatever format you want. But take a look at payload, right? Because this is the most important part when we're thinking about communication back and forth between a device-based app and the cloud. OData, which is effectively XML, we're looking at 8.5 kilobytes. Now, don't look at it for the what's in the message. Look at it from the relative to each one. Okay, with the thought of I need to transfer as least amount of information as possible. So we think about XML. XML, as you know, very verbose. Okay, so 8.5 kilobytes for that particular one. Let's look at the next one. REST XML, all of a sudden now, significantly less. 8.5 to 1.5 or 1.2, significant. Now, new world, JSON. Okay, look at the difference. Not to mention the fact that it makes it a lot simpler to read, but if we're thinking again of how do we ensure that we're transferring the least amount of communication back and forth, if we have to go to the server to pull information, obviously JSON is the way to go. Again, that's not to say it's the only way to go. That's not to say it's going to work every time. But if you can go down that route, light as payload. If you have a different way, you're coming up with a new algorithm to do this or a new method to do this, even better. As long as you're thinking, I want to make sure that my payload is as small as possible. Let's look at it from the other way now. Now this is again is an example of Windows Phone that you have here. But when we're thinking about getting this concept out of the way of polling, and we just say, yeah, you know what? Let me know when there is something that I care about. That's when we're starting to think of something called push notifications. Now, push notifications, very much so built into most of the modern devices. More importantly, now is also built into Windows 8. So now we're thinking, hey, this is some really cool stuff here that not only will allow me to reduce on the data load going back and forth, but it's actually going to allow me to enable a whole bunch of new scenarios. For example, I might have something running in the cloud that initiates a push notification back to my device. And in that I might say, by the way, here's your message. And I might just take that message and display it on the screen. The Facebook app, for example, does that. It sends the text, and that's actually what you see on the screen. Now you can even put images in there and so on and so forth. But what if your message needs to be a bit more than that? Or you just want to let your application know that there's something that it cares about. You send that push notification over to the app. The app then, in your case, you program it to know that it's basically, hey, wake up. I need to go look at at the server or the service that's running up in the cloud. I need to go and do something, right? When you see James going through his demo, that's what I'm talking about as that text that comes through the push notification. That is what's shown on the screen. In this particular case that I'm talking about here, in terms of just sending you a signal, you can put in whatever into that push notification. It might be a job ID, or it might be an address of where to go pick this stuff up from, right? Only you know what you want to put in that message. The point being is it's that you think about it almost like an alarm clock. It's a wake-up call for that application to go and do something, especially if that application is not in the foreground, right? If it's in the foreground, then yeah, you know what, you can technically every once in a while poll, whatever. But if it's not, that push notification is actually a way of bringing your application back into the foreground as far as the user is concerned, because it's like, hey, my app is alive, or it told me that something is done, I should go check it out. So that's what we're talking about when we talk about cloud-initiated communications. We're thinking about push notifications. Okay, and that's a really funky way of giving you that example with the text. Okay. Now, when we're thinking about how this actually works, basic mechanism is that, again, your device is going to send a request up into the push notification system for whatever platform that you're writing against, and it's actually going to request what's called a channel. That channel is effectively the way in which the application will then communicate back with your application when it needs to do that. So the naming or the notification system returns that channel. That is then stored in the device. Now, your app in the device will then continue about its ways, and let's say you're building an application that is in fact on a web role. Or again, you'll see in James's example using mobile services. The point is that you then start off that discussion with the server with saying, hey, by the way, this is my channel. This is the way in which you're going to communicate back to me whenever you have something to share with me. And that channel is then stored within your server-side application so that when it needs to send that notification back, it knows where to go. Now, when it actually comes to letting your application know that something is there for it, we're going to do whatever it is, whether it's on a web role or a worker role, okay? And then that web role / worker role will send the request over to the notification system that says, oh, by the way, I actually have something for this particular app. And that particular app is addressable by this channel URL. So what does the notification system do? It then says, okay, great. I will relay that message on for you. Now that toast notification comes up on your screen, and you can either display it or your application says, okay, got it. I'm going to go ahead and do something. And that something might actually be now make an additional call over to the web role or the worker role to go pick up something. Okay? So you have your full circle of communication, the idea being that in order for that to happen, you weren't constantly keeping a connection open with the server and polling it to get that data back. Okay? And especially if you're thinking about things that are long running, the last thing that you want to do is keep that connection open for that period of time. Now, that is, of course, a common pattern that, the one that we just talked about, where you're pushing things back and forth. And by no means is it the only pattern that you can do. You can use the notification systems in whatever way makes the most sense for your application. Okay? But what you should know, of course, is that the different platforms have their various different nuances in terms of their notifications. But the nice thing is that all of them have, you'll notice here, right? Windows 8, Windows Phone, iOS, Android, they all have this push notification capability. So, of course, that means that as you're writing these different applications, you have the platform behind the scenes in order to actually make this happen across your device platform. Now let's talk about some of the other things that exist within the platform just as an augment into your actual application. Right? We talked about the databases last week, but I'll briefly touch on it. That's that concept of having that relational database capabilities outside of your application. Talked about storage. Traffic Manager is actually a sweet spot for device applications because it will actually detect where you are connecting from. And as long as you're deployed into multiple data centers, your backend that is, it will actually redirect you to the data center that is geographically closest to your application. Now think about this. If I'm roaming around with a device, that's going to change every time. And that way I can get that communication back and forth going with something that's geographically closest to me, which of course means from a performance perspective, I'm going to get a lot better performance because the latency will be a lot lower than if I was connecting onto the other side of the world. If we think about things like caching, caching is a great service to use when it comes to when it comes to device-based apps, because again, you want to think about how do I get data quickly into this application. So if I'm pre-caching, let's say, data that doesn't change often, let's say stock quotes, for example, that only changes every 15 minutes. A call into the cache, and granted the cache is still in the cloud, so it's not a cache on your device, but a call into the cache is actually that much faster than if I was to make the same call against a database, for example. More importantly, think about it the other way around. If I'm saving data from my application, I could actually save it directly into the cache and then have a cloud side process to write that or read that from the cache and then write it to something persistent. Okay? So what that allows me to do is, again, bring that control back to the user or back to the device app as soon as possible and not have it worry about how long it takes to write to a database. Or I can pre-can queries or stuff like that. What you'll see a lot of device applications doing is actually talking back and forth with just the cache service, and eventually that information will get written back into either table storage or blob storage or databases. So the caching capabilities actually makes it a lot easier for you to be able to broker data back and forth a lot faster without having to worry about the infrastructure that's there in order to make it happen. Last but not least, I did want to touch upon CDN. I touched on it a little bit before in terms of the delivery of the actual content. That's to say that if I'm putting up my files, videos, documents, so on and so forth in my storage account, now of course that storage account is off the device, it's in the cloud. What that allows me to do is, if you remember when we were talking about that architecture scenario where I'm connecting directly into the storage with those shared access signatures, what that actually allows me to do is by connecting directly into the resource, so connecting directly into the storage account, even though it looks like I'm going to the one URL from my application's perspective, behind the scenes, I'm actually being routed to the node that, again, similar to Traffic Manager, is geographically closest to the device. So if you're transferring back and forth images, videos, documents, whatever it might be, especially the bigger the file, the more you care about this stuff, then you actually want to make sure that you're communicating with that node that is closest to you, not where your primary account might be, which may actually be in North America. Okay? So you have all of these platform features in order to make sure that that actually happens for you. I want to make sure that I cover some of the tooling capabilities that is available. And by the way, just so that, I guess, because it is sort of confusing, there's two ways to look at this. You can either look at it from mobile services perspective, which wraps it all nicely, and James is going to go through that in the next session. Think about these toolkits that you see here as if you need more than that. If you need something a little bit more than what you'll see in mobile services. So Windows Phone does in fact have an SDK that connects into Windows Azure, makes it nice and simple to get this stuff up and running. More importantly, it's actually optimized for the device. So some of the things that you would have in, let's say, your websites or your applications that you would put on a cloud service and work with Azure storage, let's say that way, these specific DLLs have actually been optimized for that device. So you can download that toolkit and get the additional functionality there. Similar thing for iOS and for Android. By the way, these SDKs are also open source. So if you want to modify them, fork it out, go nuts, right? Or if you don't want to use SDKs at all, if you're either hardcore that way and you like to, just get to the meat and potatoes, or something doesn't work exactly the way you want it to work, REST-based APIs for every single one of the services that you heard me talk about. So technically, you don't need an SDK. All the SDK does for you is actually just do all the plumbing for you so that you don't have to worry about it. But you absolutely can download a copy of these SDKs, use as you please to get those apps going. So just to summarize, to make sure that we are in fact all on the same page, we're thinking about, again, the picture, obviously, because that's what I have, but you can replace that Windows Phone with a Slate like the one I have in front of me. You can replace it with an iPhone, an iPod, an iPad, an Android Note, or whatever device it might be. I'm not going to sit there and list them. As long as it can access the internet, effectively, as long as it can speak HTTP, I guess you can say, and as long as it can understand REST-based APIs, everything that you've heard me rant on about for the last, what's it been now? Whatever, doesn't matter. I was trying to figure out the time from the timer that I have in front of me, but I won't bother. Point being, all of this stuff applies regardless of what platform you're using. And we think about it from the perspective of storage. Don't be the one that's using all of the storage on the device. We're also thinking about it, and I don't have a box in there because it's sort of inherent. You don't want to be the one consuming all the resources either. So again, I go back to the same example every time because video encoding is resource intensive, right? So you don't want that happening on the device. Or it may actually be that the device, whatever platform you're running, doesn't even have the APIs or capabilities to do what you want to do. So what do? Ship that up, get that working up in a worker role in Windows Azure, and just get the responses back and forth, right? Or the final result. And then you've enabled your application to do whatever it is that you want, and you're not actually constrained by the device itself. We talked about identity in terms of rather than having to build all of that on the device, or more importantly, build in all of the various different types of identities that are available these days into your application. Here you're using Access Control Service. You're making a single call out to get your authentication and authorization done. And in fact, I didn't go into this, but if you're actually interested in the Windows Azure Training Kit, which you can actually download if you scroll up on your screen, you'll see the downloads button there, or you can actually scroll down to the bottom of your page. You'll have the link there for the training kit. If you're watching this on demand, it's aka.ms/workshoptk, T like Tom, K like kite. And you can actually download this stuff. There's actually a lab specifically for giving an example of Windows Phone and Windows Azure, but if you're interested in what you can do with identity specifically, again, there's also a lab specifically for that one. Communications, we talked about this idea of device initiated. So I'm a device application. I'm polling back and forth from the server and trying to figure out if I have work to do. Or I can wait for server-initiated communications, which basically actually just allows me to sit there until I actually have work to do, and the notification system will tell me I have work to do, and then do whatever I need to do. And then we talked about some of the additional platform features that just make device applications that much easier to operate, but more importantly, I say easier for you as a developer, but actually easier from both a development perspective and a maintenance perspective for the sysadmins in us, or the people who actually have to make the infrastructure to support your applications. All of that becomes actually quite simple when you start piecing in all of these additional platform capabilities right into your application. So with that, we're actually going to wrap up this particular session. Remember, this is live and interactive, so make sure that those questions are coming into the chat. We have a whole bunch of people online for you answering those questions, and we'll take some of the good ones too, and we'll also address them at the end of the day. We'll take a short break for now, and when we come back, we're going to see Mr. James Chambers, who's actually going to go through I don't want to call it a simplified version of what I went through right now, but it's actually taking these concepts and wrapping them into a service that actually makes it easy for you to implement, yet not take away functionality at the same time. So stay tuned for that. We'll be right back, and we'll kick it off then.